You know, every single day with just one click or a tap or a swipe, we're sending these little digital pieces of ourselves out into the world. But have you ever stopped to think, where do they actually go? What kind of journey does that data take? Well, today, we're going to follow the path of one single click and uncover the absolutely incredible journey it takes from your screen all the way to the cloud and back again. I mean, really think about it. You click buy on something, you like a photo, you shoot off an email, that one tiny action kicks off this lightning-fast chain reaction that spans the entire globe. So what is really going on in that split second? That's what we're going to break down step by step. All right, section 1, your digital front door. So our journey starts right where you'd expect, with the device in your hand or sitting on your desk. This thing is basically your personal gateway to the entire digital universe. These are what we call access devices, and they come in all sorts of shapes and sizes. I mean, of course, you've got your personal computer and your phone, but it could also be your smart TV, or maybe one of those multimedia kiosks you see at the mall, or even a super tiny RFID tag on a product. Every single one of them is a starting line for your data's big race. So, in the tech world, this whole part of the system is called the front end. It's pretty much everything you can see and interact with: the screen, the buttons, the whole interface. It's the part that's built specifically for you, the stakeholder, to use. Okay, section 2, connecting to the network. Your click has officially been registered on your device. But for that click to actually do anything, it's got to leave the nest, right? It needs to hop onto a local network to start its big journey out into the wider world. So, first things first, your data jumps onto what's called a local area network, or a LAN for short. This is super simple. It's just your home Wi-Fi or your office network, the thing connecting all your nearby devices. But to go any further, it has to connect to a wide area network, or WAN. And that is the big picture, the network that connects devices across cities, countries, and even continents. And what's the most common way it makes that first leap from your device to the LAN? Yep, good old Wi-Fi. It's basically an invisible bridge. It creates a little local hotspot that lets your data wirelessly jump from, say, your phone over to your router, getting it all packed and ready for the next leg of the trip. Section 3, crossing the global internet. Okay, our little data packet has officially left the building, and now it's time for the main event, crossing the huge, sprawling, interconnected web of networks that we all know as the internet. You know, what's wild when you look at this timeline is just how new all of this stuff is. The internet as we know it got its start way back in 1969 as ARPANET. It was a project from the US Department of Defense, and it only linked up 4 university computers. Just 4. And the amazing thing is, it was designed from the very beginning to be decentralized and resilient, a core idea that still shapes the internet today. Okay, so to get around this massive global network, all our data has to play by the rules. A very strict set of rules called TCP/IP. The best way to think about it is like a combination of a universal language and the global postal service. It's the protocol that says exactly how data should be packaged up, addressed, sent out, and then confirmed once it arrives. It's the reason a message from a Mac in Tokyo can show up perfectly on a Windows computer in Toronto. And just like any good postal service, every single package needs an address. It's no different on the internet. Every device that's connected gets its own unique IP address. It's literally a digital street address. It tells the entire network exactly where to send your data, and just as importantly, where to send the reply back to. Now here's a really cool part. Your data doesn't travel as one giant file. Instead, it gets broken up into these tiny little pieces called packets. I want you to imagine trying to mail a book, but you send it one page at a time. Each single page, each packet, gets its own address label. Then, routers, which are like the traffic cops of the internet, look at each packet and send it along the best possible route. And get this, they might all take totally different paths to get to the same place. Then, once they all arrive at the destination, they get put back together in the right order. This whole system is called packet switching, and it's what makes the internet so incredibly resilient. It's the reason why when your video call gets a little glitchy, it can fix itself in a second. It doesn't have to restart the whole thing, it just asks for the missing packets to be sent again. Genius, right? All right, section 4, arriving at the cloud. So after that unbelievable trip across the world in just milliseconds, our little packets have finally reached their destination, the cloud. So what is the cloud really? It's definitely not some fluffy white thing up in the sky. The best way to think about it is like a utility, just like electricity or water. You don't have your own power plant in your backyard, right? You just plug into the grid. Well, the cloud is the same idea. Instead of companies owning and running their own massive, expensive servers, they just rent the computing power they need from these gigantic, specialized data centers. And companies can use this cloud in a few different ways. Think of it like a sliding scale of do-it-yourself. At the bottom, you have Infrastructure as a Service, or IaaS. This is like renting an empty plot of land and a pile of bricks. You manage almost everything yourself: the operating system, the data, the applications. A step up from that is Platform as a Service, or PaaS. This is more like renting a fully equipped workshop. The platform is there for you, so you just have to manage your own applications and data. And then, at the very top, you have Software as a Service, or SaaS. And this is the one most of us use every single day. Think about Gmail or Netflix. You don't manage anything, right? You just use the software. The provider handles everything behind the scenes. So this whole cloud setup, this is the back end. Remember the front end from the beginning? That was the part you could see and touch. Well, the back end is everything else. It's the warehouse, the engine room, the brain of the operation. It's where your click is actually processed, where databases are searched, and where the response is put together to be sent all the way back to your screen. Section 5, our data-driven world. So there you have it. The journey is complete. Your click made it. But now let's zoom out for a second, because that journey we just followed, it's happening billions of times every single second, all around the globe. And that creates a world that is just swimming in data. This nonstop flow of information has given us the era of big data. And it's usually described by what they call the 3 V's. First, there's volume. We're talking about an unbelievable amount of data, truly massive data sets. Then you've got variety. This data isn't all neat and tidy. It's coming from all over the place in different forms: text, pictures, videos, you name it. And finally, velocity. The speed at which this data is being created and processed is just mind-blowing, often happening in real time. But why? Why collect all this data? Well, this quote really nails it. The aim is to use such intelligence for better business decision-making. That's the whole point. By sifting through all this information, companies can spot patterns, gain insights, and hopefully make smarter, faster decisions. Of course, when you have all this incredibly valuable data zipping around the planet, protecting it becomes absolutely crucial. Think about it. At every single step of that journey we just mapped out, from your phone, across the internet, to the cloud, and back again, your data is potentially vulnerable. Data security is the shield. It's the process of protecting that data from all sorts of threats. And one of the biggest tools in the security toolbox is encryption. There are 2 main flavors. First, there's symmetric encryption. This is pretty straightforward. It uses one single shared key to both lock and unlock the message. Think of it like you and a friend having a copy of the same house key. Then there's asymmetric encryption, and this is the real powerhouse of the internet. This is what's behind that little padlock you see in your browser. It uses a pair of keys, a public key that anyone can use to lock a message and send it to you, but only your private key can unlock it. It's the foundation for pretty much all secure communication and online shopping. And that brings us to the big final question. We've just walked through the entire journey of a single click, but today it's not just our computers and phones. We're in the era of the Internet of Things, where everything from our cars to our coffee makers is coming online. So as billions upon billions of new devices start sending their own data on this exact same journey, you have to wonder, how on earth are we going to protect all of it? How do we secure this absolutely unprecedented explosion of information? It's something to think about for sure.